Before we begin, I want to make a point of clarification. In the last video, I showed this quantity like it was a magnitude instead of the absolute value of a dot product. Remember, the dot product returns a scalar, and so we need the magnitude here. And the reason for that is that when you're doing the dot product of two vectors, you could end up with a negative if they're in opposite directions. And when we talk about a distance from a point to the plane, the normal might be pointed in one direction, but that PQ vector might be pointed in another one because the point is below the plane. So we always take a look at the absolute value. So I apologize for that mistake. Anyway, we talked a little bit about the theory behind the distance from a point to a plane, but let's do a practical example using an algorithm here. So to find the distance from the point Q to a plane, we need to get point P in the plane, and we can do that by solving the equation to find a point. We can find the directed line segment PQ. We can find the normal vector, usually from the equation of the plane. We find the dot product. We find the magnitude of the normal vector, and we put it all together. So let's do an example. If I have some point, 1, 3, negative 1, and I have a plane, 3x minus 4y plus 5z is equal to 6, we want to find the distance from that point to that plane. So, the first thing is to find a point P. Well, if I set this point, or if I set y equal to 0 and z equal to 0, then I get the point 2, 0, 0. And that satisfies the equation, so we know that it's a point in the plane. The second one is to find the directed line segment from here to here. So that is, you got to go negative 1, positive 3, negative 1. That gets me the directed line segment from P to Q. The third statement is how to find that normal vector. Well, if you remember, we can get it from the coefficients of the equation of the plane. We want to take that dot product here, so that's going to get us negative 3, negative 12, negative 5. Or rather, we do that, negative 3, negative 12, negative 5, which gets us negative 20. And to find the magnitude of n, we square each one and sum them up. So 3 squared plus negative 4 squared plus 5 squared. And that's going to be 5 square root of 2. It's 9 plus 16 is 25, plus 25 is 50, which gets us 5 root 2. So to put it all together, take the magnitude of PQ dot n over the magnitude or length of n, and that's the magnitude of 20 over 5 root 2, which is 20 over 5 root 2, which simplifies to, let's see, that's 10 root 2 root 2, 2 square root of 2 is the length or the distance from this point to this plane.